Good evening. Tonight we're going to talk about the hypothesis. A hypothesis is a prediction made about what might happen in an experiment. It's important that your prediction is not a blind guess. A hypothesis is not a guess. Instead, it's an educated prediction that should be based on research. So normally, if you were designing a scientific experiment, you would go away and read as many different reports of other people's similar experiments as you possibly could. And from those, you would form a hypothesis, a prediction about what would happen in your experiment. That isn't always possible because you've got so much other work to do. So at the very least, your hypothesis should be an educated prediction based on your prior experience. Okay, let's have a look at some predictions. Back in the floating eggs activity, there were probably two good predictions that could have been made. The first one might be that adding more salt to the water will make the eggs float. The other one might have been that adding more salt to the water will not make the eggs float. Notice that your prediction doesn't have to be right. There is no requirement at all, no extra points if your hypothesis turns out to be true. In fact, many of the most significant discoveries in the history of science started from hypotheses that were found to be incorrect. All right, now, there's a difference between a hypothesis and a prediction. We've seen some predictions. So an example would be, adding salt to the water will make the eggs float. That's a prediction, but it's not a hypothesis yet. And that's because a hypothesis should be written in a particular way. It's quite difficult to get your head around this at first. You should always follow this format. If something is related to something else, then as one thing changes, and those you have to be specific about the changes, then the other thing will also change, and again be specific about how it will change. So the first thing is your independent variable. You need to know that after the floating eggs activity. So if the independent variable, whatever that is related to the dependent variable, whatever that is, then as the independent variable, now choose a word, increases or decreases, the dependent variable will, and then you would say increase or decrease, something like that. So you're linking your two variables together, your independent variable and your dependent variable. You're linking them together in an if-then statement. But you're also being particular about how the change is occurring. It's not just changing, but it's increasing or it's decreasing. Right, that was a lot. Let's have a look at an example. Remember, we had an example about an experiment to determine if loud music is distracting. The hypothesis in this case might go something like this. If the volume of music is related to how quickly a person can count backward from 20, then as the volume of music increases, the time people take to count backward from 20 should increase. So, have a look at the colors. The colors here are important. I colored my independent variable red. That's the volume of music. I colored my dependent variable blue. That's how quickly a person can count backward from 20. And then I colored my change green, and in both cases that's increase. Because if you're distracted, it will take you longer. The time will increase for you to count backward from 20. All right, watch that back again and come to class with any questions that you might have. We'll do some more practice problems in the lesson tomorrow so that hopefully it will be a little bit easier.